Basic
Math Teacher Society.
Basic Education Math Teacher Society.
To encourage and stimulate excellence in mathematics and its application by conducting seminars and workshops for mathematics teachers.
To encourage and provide opportunities for the exchange of ideas and materials related to instruction of mathematics by holding annual research conferences.
To further the cooperative study of problems related to the teaching of mathematics and the basic education by promoting action-oriented studies and
work for the improvement of mathematics and instruction at all levels of education by holding fora and symposia where experts in the field of education and math teachers exchange relevant dialogues.
In line with the organization's tagline and objectives, the organization holds the following activities, but not limited to:
research conference, summer workshops, trainings, action research projects, forum and symposium, needs assessment, and quiz week.
Benefits of the members.
Certificate of membership with unique membership ID number.
Discount on training and research conference fees.
Priority on special trainings sponsored by the BMTS.
Priorities in events and activities sponsored by BMTS.
Opportunity to join or collaborate research projects. And opportunity to be appointed as speakers in trainings and seminar workshops sponsored by BMTS. In order to achieve our main objectives, we aim to hold seminar workshops and trainings for math teachers, hold research conferences, conduct collaborative researches with math teachers in the Philippines, and hold symposium, fora, where field experts in education and math teachers exchange relevant dialogue. For membership details, contact any of the BMTS officers or BMTS division representatives.
Good day to all our viewers watching live from MTM channel, the official YouTube channel of the Mathematics Department of Schools Division Office of Mandaluyong City, as well as to our Zoom live viewers for today's session. Welcome to the second day of the 3-day National Seminar Workshop on Conducting and Interpreting Factor Analysis in line with the celebration of National Teachers Month. This is a webinar series conducted through the initiative of Basic Education Mathematics Teachers Society, Incorporated, in collaboration with Schools Division Office of Mandaluyong City, Marikina City, and Parañaque City. I am your host for today, Sir Ray Collado from Highway Hills Integrated School, DepEd, Mandaluyong City. Before we proceed with our program, let us have a few announcements. Next year will be the 2022 Basic Education Mathematics Teachers Society International Research Conference, which will be held virtually, having the theme Connecting the Links of Science, Technology, Engineering, and Mathematics for an Enhanced Mathematics Teaching Learning Process in the New Normal. The 2022 bmts Research Conference is open to any interested mathematics enthusiasts, which range from undergraduate to postgraduate and graduate students, professional teachers, to the mathematics researchers. This conference is an opportunity to learn, discuss, and collaborate with fellow mathematics education researchers. The schedule and venue for this 2022 bmts International Research Conference would be on January 27 to 29, 2022 via Zoom platform. This is co-organized by Department of Education Region 7, St. Paul University of Dumaguete, and Negros Oriental State University. The 2022 conference activities would include the following. First is the plenary sessions. Second, research paper presentations. Third, demonstration teaching. Fourth, workshops in mathematics, teaching and learning. And fifth, Math Calculympics. To those who wish to present their papers, workshop, demo teaching, submit your abstract through the Google form posted on their Facebook page, the BEMTS Inc. Again, their Facebook page is BEMTS Inc. The abstract is composed of 250 words and should be informative for proper evaluation by the program committee. Participants will be notified for possible acceptance as soon as possible. The deadline of submission is November 15, 2021. For additional information and further directions, please email Dr. Rodolfo T. Onzo Jr., the President of BEMTS Incorporated, and Dr. Craig N. Refugio, Vice President for Research and Extension of the same organization. Their emails are posted on your screen. Also, for other details, you may contact the coordinators from our co-organizing teams. The names and cell phone details are posted on your screens as well. At this juncture, may I remind everyone to please fill out our attendance form. Please go to bit.ly/FA Day 2. Again, please go to bit.ly/FA Day 2. This link is also posted on your screens right now for your reference. To formally begin our program, let us sing the Philippine National Anthem. This is to be followed right away by a prayer.
Mga kababayan, ang pambansang awit ng Pilipinas.
Kayang magiliw ay masasiranganan, alam ng puso sa dikit mo'y buhay. Lupang binirang buyagan ng magiting, sa manduluping di ka pasisigil, sa dagatang tutok sa simoy at sa langit kong bagaw, ay hinagang tula kawit sa pagkayang minamahal. Ang isang ng matawag mo'y tagumpay na nagtitigil, ang bituin at araw niya kailan pa may magtitigil. Lumanang araw ng warhabit pagsingka, mo'y langit sa piling mo. Ang hinigaya na partay mga hangin, ang mamatay ng dahil sa'yo.
Let us pray. Dear Almighty and ever-loving God, we glorify your name. You have showered us with so much blessings, and your presence continuously reminds us of your faithfulness and guidance. Lord, may we humbly ask for you to shower our speakers today with your greatest inspiration so that they may share the most of their knowledge, heart, and soul to the respective topics. May we also absorb the invaluable knowledge and experiences and put this into practice. We pray that you bless all the committee in charge, that they may be able to fulfill their tasks responsibly, and the objectives they have set may all be achieved. May your infinite grace lead to the success of this seminar, and may be the living witnesses of your genuine love, through the enactment of knowledge acquired through this activity. We ask this in the name of Jesus Christ, our Lord and Savior. Amen.
Again, may I remind everyone to please fill out our attendance form. Go to bit.ly/FA Day 2. bit.ly/FA Day 2. The link is also posted on your screen for your guidance. This time, let us hear the welcome remarks from the Vice President for Finance of bmts and an instructor of University of San Carlos. Let us welcome Ms. Catherine E. Lantixe.
Learning never stops, so teaching and learning must go on. To all of us here, committed, hardworking, and passionate educators, our speakers, you, our participants, and our organizers, good morning. Welcome to the second day of this webinar workshop on conducting and interpreting factor analysis. With the pandemic that we are experiencing, teachers needed to be flexible and resilient. We made preparations and adjustments for education to thrive. Here in the Basic Education Math Teacher Society Incorporated, we bear the tagline, "Excellence in Math is our priority." Thus, having this webinar workshop. You can't give what you don't have. Cliché as it may seem, sit back, relax, and enjoy learning and relearning on conducting and interpreting factor analysis. With that, I thank you ahead and good morning once again.
Thank you so much, Ms. Lantixe, for the warm welcome. This time, let me introduce the speaker for today's session. Our speaker for today is a progressive mathematics educator. He was awarded as one of the 10 outstanding teachers by the Department of Education in Lapu-Lapu City in 2016 and was nominated for the Metrobank Search for an Outstanding Teacher in 2017. His stint at the Cebu Normal University has provided him with the opportunities of receiving the following Presidential Citation Awards. First is the Outstanding Performance in the Delivery of Instruction for the year 2018 to 2021. Another one is for publishing research paper in Scopus Index journals and for contributing in achievement of the CNU's strategic direction. Mr. Ray Ferdinand M. Gagani has conducted trainings, seminars, and write-shop at the national, regional, division, and school levels. He is a Doctor of Philosophy in Education, major in Research and Evaluation candidate. Currently, he is the Vice President for Education of the bmts. Again, ladies and gentlemen, join me in welcoming our speaker for this day, Mr. Ray Ferdinand M. Gagani.
Good day, everyone. My name is Ray Ferdinand Gagani. Today, I will talk about factor analysis. But before that, let me share first about how crafting a tool that is assumed to measure a construct, for example, intelligence, anxiety, or level of satisfaction are done. And what are the psychological and measurement aspect that needs to be investigated. There are major concerns in instrumentation. These are the instrument's validity, reliability, and dimensionality. Validity pertains to the appropriateness of the instrument in measuring a construct. This is the first concept that a researcher needs to reconcile when the research study entails measuring a latent variable, a concept that cannot be measured directly. Validity tries to answer the question, does the instrument can measure what is needed to be measured? Validity can be evaluated or validated by investigating the following: the content validity of the instrument, its construct validity, the concurrent and the predictive validities, and the generalizability or the reproducibility of the measure. Reliability, on the other hand, is the characteristic of the instrument in reproducing the same measure when it is administered at different times to a single group of people, or when it is administered to two or more separate groups of people with the same characteristics. Usually, we use correlation value in checking the reliability of the instrument. We can do this by test-retest method. We can also check the internal consistency among the items in measuring the construct that we want to measure. The third concept, which is dimensionality of the instrument, refers to the number of factors that can contribute to the variation of the measure. An instrument could be unidimensional or it could be multi-dimensional instrument. A unidimensional instrument measures a single construct, while a multi-dimensional instrument measures two or more constructs. There are two schools of thoughts that we can actually adapt when developing an instrument. One is the classical test theory approach, and the second one is under the latent trait model. The classical test theory approach is focused on test-retest reliability, internal consistency, validity, normative data, and standardization, while the latent trait model is focused more on how specific items function in assessing a latent trait. One consideration when we develop a new instrument is whether the instrument can measure the construct that we want to measure. According to Cronbach and Meh, a construct is defined as some postulated attribute of people, and it is assumed to be reflected in the test performance. Usually, when developing a new instrument, we undergo the following processes. Number one, we need to identify the construct to be measured. Second, we need to identify item representation, or we make items, we call it factors. The third one is we validate the item representation with experts on the field to establish the content validity or ground the items on published research literatures or theories. Then we validate the tool if it is function as intended. After which we need to build a scale. And if it needs to be improved, we need to remove items if necessary after validation, and then validate it again if necessary. One way of investigating the content and the convergent validity and the dimensionality of an instrument is by following the classical test theory through data reduction techniques. This is where the beauty of principal component analysis and factor analysis, called exploratory factor analysis or EFA, comes in. Principal component analysis, or the PCA, transformed the items, or also known as the manifest variables, into a new and fewer uncorrelated variables called principal components, each of which represents a dimension in the data. On the other hand, in factor analysis, the original variables are considered to be indicators of underlying dimensions called the factors. That is according to Blanche. The principal component and factor analysis are analytic technique for transforming a number of items or datasets into a more interpretable form. While it, it appears that PCA is sometimes considered as factor analytic technique, but in theory it is not. Hence, in PCA, the underlying factors that affects measurement is not considered. Rather, in PCA, we create an index through the summated weights of each of the manifest variable. Just like, for example, in this figure A, if you want to come up with ideal weights based on the strength of the correlations among the 7 variables and come up with a linear combination to form a single index score. But in figure B, we're trying here to measure an underlying construct or a latent trait, let's say, for example, intelligence, which is present in the 7 manifest or observed variables. Let's say variable 1 is a test score in mathematics, variable 2 is a comprehension test score, and etc. As observed, there is also this variable u that is unmeasured, which is causing a unique variance that is not captured by the underlying value of the latent trait. Now, for example, in figure B, the variance of b sub 1, which is considered, or let's assume that this is test scores in mathematics, is caused by a person's intelligence. However, there is, or there are, another unmeasured variable, let's say u sub 1, which of course could be, let's say, a lack of sleep, or the student or the person did not study hard, that also contributes to this variation. Now, there are analytic techniques for examining or studying non-experimental data, just like the data that we gather in social sciences or behavioral sciences. Now we could use this to test theory or to develop test instrument. One of which is the principal component analysis, and the second one is we have the factor analysis, which could be exploratory type or a confirmatory type factor analysis. Now the only difference between a principal component analysis and a factor analysis is that the principal component analysis it's a reduction technique, which of course exploratory in nature, which uses linear combination of items to form a index score. While for exploratory factor analysis and confirmatory factor analysis, still they are data reduction technique, and exploratory of course is an exploratory approach while a confirmatory is a confirmatory approach, but the two are modeling techniques which extract factors and explain their relationships. Now, suppose we want to develop an instrument that could measure a certain Latin trait. We want to have this developed with a high psychometric value. And so we can use factor analysis to do so. Now, factor analysis is a technique that we can use to reduce the number of variables into fewer variables, and we can use this to understand and to explore our data sets and confirm what we previously found out to be true. Now, in instrument development, we usually identify first the latent trait to be measured, and then we use theories, we use previous published research to determine the possible indicators of that latent trait, and then we write items. After which, we collect data and we run an analysis. Let's say, for example, we run a factor analysis to make this set of indicators more interpretable by transforming them into cluster of factors. Now again, when we try to develop a new instrument, we need theories, we need previous research studies to back up how do we come up with the idea or the operational definition of the construct that we need to measure or that we want to measure, and then we assign enough items that can lead to measuring the said construct, and that we want to make this few as much as possible so that we can easily interpret our findings. Now, we employ data reduction techniques not to reduce the number of factors in that case or in this case. Now, there are points to consider. There are points to consider in performing factor analysis. Now, again, theoretically, the items should be a good representation of the construct. Of course, this entails us that we need to refer our judgment to theory and published related studies. Then we collect the data and we find an instrument. And again, we can use factor analysis. Specifically, in this example, we'll be utilizing the exploratory factor analysis techniques, which is somehow can be considered as an art of utilizing our working knowledge about factors and the relationship or the indicators and the relationship or the relationship among the indicators to its factors. Now, there are considerations before we can conduct a factor analysis. We will try to examine first whether the data that we gather is factorable. And there are different authors, there are different techniques and procedures that we can follow in doing so. The first thing that we need to do is, again, to decide whether the data sets can be factor analyzed. The first step that we need to do, according to Tabashnik and Fidel, we can examine the correlation matrix of the items and then refer to the absolute value of the correlation threshold, which is at least zero point 0.3, but other authors suggested 0.4, just like Bunch suggested 0.4. But again, we can use also 0.3. Then the next step is to check the Bartlett's test and the Kaiser-Meyer Otten measure of sampling adequacy for the QMOMSA. Following the following rules, according to Kaiser and Rice, if the Bartlett's test is significant, it is less than 0.001 or less than 00 or less than 0 or 0.05 and less than 0.0001, then we can consider or we can say that the matrix could be factorable. But we need to proceed also identifying the QMO value. Now, according to Kaiser and Rice, 0.8 or above 0.8 and 0.9 or above 0.9 can be considered meritorious or marvelous respectively. So we can have this threshold in identifying the factorability of our correlation matrix. The next thing is that we need to examine the contribution of individual items to the relationship of the correlation matrix and the potential factor solution, meaning how many factors that we need to retain. Here, if in case there are correlation value less than 0.3, or if the value doesn't correlate well with the other one, so according to field, we can remove the items. Next is we need to check if the data sets has an issue of multicollinearity. And this happens, according to field, when there is a bivariate correlation of 0.8 and 0.9 and above. So that's according to field. So let's say, for example, if there is a value of the correlation matrix, which is 0.85, so it tells us that maybe there is this existence of multicollinearity issue. But again, we need to consider other factors in our investigations. One of which is that we can determine the determinant of the correlation matrix, and if it is close to 0, then there is a problem. Now, Field also suggested that the determinant or the value of the determinant should be greater than 0.0001. That's so. If the value is greater than that, so we can proceed with the analysis. Now, if we are sure now that the correlation matrix is indeed factorable, then we can run factor analysis. Since our instrument is new, then we can conduct exploratory factor analysis if the correlation matrix is again factorable. And in Spss, we can do it through extraction of those factor loadings, and then we can conduct rotation techniques, and then we interpret the result. Now, before we can conduct rotations, we need also to consider the following scenario. Let's say if the instrument is unidimensional, meaning it only measures one construct, then we don't need to rotate. We don't need to conduct rotation technique. But if it is multidimensional, we need to ask this question: does each item loads on a single factor, and that the factor should be again greater or equal to 1. If no, then we can proceed to orthogonal rotation. So orthogonal rotation says that the factors, the factors shows correlations. There is correlation between factors. Uh, I mean, when again, when the value when the value is greater or equal to 0 or less than 0.3. So, and if we think theoretically that the factors are uncorrelated, then we can use orthogonal rotation. However, if the value is greater than 0.3, and theoretically we can say that the factors are correlated, then we can do oblique rotations. Later on, we will know what are these oblique rotation techniques and what are these orthogonal rotation techniques. Again, if the factors shows correlation, then we need to rotate that one, and that is oblique rotation. We use oblique rotation techniques. But again, if the factors are not correlated, then we need orthogonal rotations. So let's have some example and demonstration in Spss. Okay, so I have here data sets. Let's assume that these data sets came from a newly developed questionnaire. So let's have this label here are the questions or the situations in which the participants need to agree or disagree. Let's say if they strongly disagree, they will give 1 point. If they strongly agree, they will give 7 points. So here in our data view, so here are our items. Again, this can be considered factors here, and then in the row here represent the number of people who answer this instrument. In this case, there are 253 people who answer this instrument. Again, let's suppose this is a newly developed instrument that measures something, and we want to factor analyze this one, meaning we try to reduce these items and group them together to form factors. So first, we need to check if the correlation matrix is factorable. So we need to go to this dimension reduction. Okay, we have here dimension reduction, and then go to factor. There. So here I suppose I did not select yet the data sets here. So usually this is what will appear during the first run of the data sets. So here I will select all the data and then transfer it to this window, and then I'll click descriptives, and then I will click this univariate descriptives with initial solutions, and then check the coefficient to create a correlation matrix. You can also have the significance level, but not necessary. And then the determinant, and then we have the KMO and the Bartlett's test of sphericity. And if you want to check the anti-image, you can do so. You can still follow the suggestion of Kaiser and Rice. So we need to look at least 0.8 value of the diagonals of the anti-image matrix. But in this case, I will not do the analysis for the anti-image. Here, I want to check first whether the correlation matrix is factorable. So I will click continue. So here we need to have the extraction. So the default the default factoring method of SPSS is the principal component. You can do this one, the principal component, if you want. But again, we can also do the factor analysis when we want to consider other factors that might affect the variation of a certain observed traits. Let's say performance in mathematics. We have, say, your score in your English class. So I will check this I will choose this principal axis factoring in SPSS. This is factor analysis. Again, principal axis factoring is the is the factor analysis in SPSS. Again, the principal component and principal axis factoring, although they are reduction techniques or data reduction techniques, but they are different in theory and in function also. So I will choose the principal axis factoring since I want to conduct a factor analysis. So I will click this script plot and then click this correlation matrix, and notice that I already have selected this one, but I will not do it now because the default in SPSS is that this one, based on eigenvalue, since we are still exploring, and then here the eigenvalue according to the rule is that it should be greater than 1. Now, some authors recommended the use of the eigenvalue in examining the number of factor solutions to be retained. When the methods is principal component analysis, but other authors when suggested that when you conduct factor analysis, it is not necessary that you base the factor solution based on eigenvalues. So here, the maximum iterations here tells us how many iterations that the loadings or the items that loads a factor converge. Now, for smaller sample size or few participants, it is advisable to increase this iteration. But in this case, we will not be changing this one. So let's continue. And again, since I am not sure yet if this is factorable and whether we need rotations, so I will not conduct a rotation analysis. So I will just check this one none. Okay, and then continue. And then here in the scores, you may report these values, but not necessary. This one, the regression, the Bartlett, and the Anderson-Robin, but not necessary. And here in the options, if there's no missing value, so we have exclude case that's twice, and there are no missing values here. Here, there is this sorted by size, so I will uncheck that one. And I will not applying this suppress small coefficient value since I am still in the process of identifying whether it is factorable. And click continue, and then click OK. And then here, SPSS reported as this beautiful window. So here, in the descriptives, it tells us that there's no missing data and there are 253 cases contributing to the variance here. And then let's examine the correlation matrix. So again, if there is a correlation matrix, a correlation coefficient among or any paired variable, which is 0.8 and above or 0.9 and above, then it might suggest that there is an issue of multi-collinearity. But again, we need to further check this value, the determinant. Again, the determinant value should be less than. Again, the determinant value should be less than 0.05 or 0.00001. Okay. Now, the KMO, we need to consider the Kaiser and Rice terminologies for identifying some adequacy. Now, remember that according to the rule, point 8 is considered meritorious and point 9 and above is marvelous. So in this case, we are now have an assurance that this is the matrix here. The correlation matrix is indeed factorable. Okay, and then we have the Bartlett's test of sphericity. Again, if the Bartlett's test of sphericity is significant, meaning if it is less than 0.05, then we are sure that it is factorable. So this matrix is, according to the rule, is indeed a factorable correlation matrix. Now let's go again. Let's go back to this correlation matrix. So again, we can in my experience, I usually check this one and remove items first when there are items that is not correlated with other items, or meaning if the value is less than 0.3, so I usually remove. But again, that is only my technique. But theoretically, you need to further explore before removing the items. Okay, so next is again we need to check also the correlation if there's no issue of multicollinearity. In this case, there is none. And again, we can also request the correlation matrix of the anti-image and then examine the diagonals and apply Kaiser and Rice criterion. If we have 0.8 and above, then we can consider that it is a good indication that the matrix is factorable. So here we are sure that we can factor analyze this one. And so we need to proceed now to factor analysis and conduct rotation techniques if possible. If we assume that the factors are uncorrelated, then we can conduct orthogonal rotation. And if we believe by theory that the factors are correlated, then we can conduct oblique rotations. So here, as you can see here, the eigenvalue in this first exploration, it seems that this gives us a 4-factor solution here. The first factors, second, the third, the fourth factor as defined or as supported by the eigenvalue, which is above 1. And it contributes here, the 4 factors contribute about 58, or this is 57.9% of the total variance here, this one. And some authors suggest that if the total variance is 0.6, 0.7, then that is considered good. Other authors consider above 50 can also be accepted. But again, if we do factor analysis, we are not really sure that that there are that there are these unique variance contributing to the total variance of our observed variable. Let's say we have an observed variable of comprehension test scores, and then we know that that comprehension is affected by the person's intelligence level. However, there are considerations to other factors. Let's say, how about if the test taker has a problem on that day, or she is ill during the examination period, and so it could contribute to the variance. And so that's why we need to conduct a factor analysis and sometimes disregard the idea of having above 50% variance should explain, or point or 60% or 70%, as long as in theory you are supported, then it is quite well. But here, as you can see, during the extraction of these factors, it may suggest that there are actually three here. As if we consider the eigenvalue here, after it is extracted, the sums of square loadings here. As you can see, the fourth factor, the eigenvalue is less than 1. And so it gives us an idea that maybe there are actually three good factors that explains the variance. And so we can proceed the script plot here. And so then we can draw a line from this point. As you can see, this is the elbow of this script plot. The indicator is that it tends to begin to stiff off. So this is an indication that this is now the elbow of the script plot. And then we can draw a line here, a vertical line passing through this oval, and another line here. The eigenvalue, which is approximately 1 here at the center. This is 0, and then we have 1, and this is 2. So the eigenvalue, which is 1 here. So remember, this is the axis here is the eigenvalue against this factor loadings, or the factors rather. So we have here to draw a horizontal line here. And so the intersection of that is our determining guide. So somewhere here it intersects at this side, and then usually I look up the oval above the intersection, and so it tells me that I should have three factors. I have here factor 1, 2, 3, and it could be the possible factor. Now we are now sure that the matrix or the correlation matrix is factorable. So I will now begin factor analyzing this one. So let's go to analyze. So go to dimension reduction and select factor. So I have done this already. We have to extract the script plot. But since I am now sure that I have three factors, so I will click this one, fixed number of factors, then I have 3, then continue, then I go to rotations. Now suppose in theory that the factors that I investigate is uncorrelated, then I can use orthogonal rotations. One of the common technique of orthogonal rotation is the varimax. Otherwise, I will use the direct oblique. Now, if you click direct oblique for oblique rotation, 0 here means that it is a very correlated factors. So here I will click varimax, and then rotation solution. Okay, rotated solution rather, and then I will click continue, and then let's have the option here. So I want to make it more interpretable for me, so I will click this one, sorted by size, and then I want to suppress the coefficient. Other authors suggested it should be below zero point 0.3, but Bunch also suggested this zero point 0.4. So in this case, I will choose zero point 0.4. Okay, that one. So click continue and then click OK. So let's factor analyze this one. So the correlation matrix is just the same. The determinant is just the same. And then the KMO and the Bartlett test are just the same. Now let's go to this total variance explained. So here, as you can see, there is a change of our eigenvalue from the initial eigenvalue to the extracted sum of the squared loadings of the eigenvalue here. Okay. Then after rotation, as you can see, we have this the factors explain 45% of the variance here. So after being rotated. Here, again, the eigenvalues here changes. So we have 6, here we have 5, we have 4, then we have 4. So it suggests the possible number of factors on that loadings. So again, we have script plot. As you can see, since I have 3 factors now, so I can retain here, this is factor 1, factor 2, and factor 3. So this is above this elbow. And then we have the factor matrix. As you can see, this item here loads to 2 dimensions. So we have here dimension 2, factor 2 and factor 3. So sometimes our option is to delete that item and run an analysis again and examine what happens. So again, our steps should be guided, or what we do is it should be guided with theories. Now let's go to the rotated factor matrix. As you can see, this is what we are interested after we employ a rotation technique. So it was discussed already by Dr. Refugio. What is rotation? It's a matter of how we see the items being placed to a certain perspective. Let's say we have the R2 plane and then it is rotated. So here we have these items loading on item 1. These items is loading on, these items loading factor 1. This group of items is loading to factor number 2, and then this set of items loads to factor number 3. Okay, and so we can also check the correlation here. So here, factor 1 is not so much correlated with other factors. The factor 2 is somehow moderately correlated with item number 3, and then factor 3 again. Okay, so it is correlated with factor number 2, or factor number 3 is correlated with factor number 2. Okay, so suppose this is again the newly developed instrument, and so we can assign now names of these factors. So again, the naming should be based on theoretical perspective, and try to discuss with your peers or experts if these items is reasonable enough to be placed or to be named such a labeling of this factor. So again, once again, this is Ray Ferdinand Gagani of Cebu Normal University. Good morning.
Thank you very much, Professor Gagani from Cebu Normal University, for the very comprehensive discussion about how do we use SPSS for factor analysis. Now, may I ask everyone if they have some questions, you could type in our chat box or the comment section of our YouTube live. By the way, we have 70 live viewers from YouTube channel, MTM channel, and currently we have 34 participants in the Zoom. So if you have some questions, you may use the comment section for the YouTube viewers, and for our live viewers here in the Zoom, please use the chat box. Anyone po? Okay, let me just check our YouTube live. There are just some greetings here, and there are still no questions. How about for our Zoom participants? Anyone po? All right, it seems that there are no questions. So before we proceed with our workshop, may I ask some words from our speaker, Sir Gagani? Hello, sir. Okay, let me just open the unmute button for now. There you go, sir.
Hello, good morning, everyone. Thank you for participating in this webinar series about factor analysis. So I hope you learned from my discussion on how we can develop our research instrument, for example, or if you want to develop an instrument for psychoeducational testing. This is just a chunk of instrument development because there are many procedures that we can do in instrumentation, and then we can also choose a certain model. Let's say, for example, if we want to use the latent trait model, so we can also do that. Here, exploratory factor analysis or factor analysis per se is a type of analysis under the umbrella of the classical test theory. And so there is this another school of thought, which is the latent trait model, in which it investigates how the function or how each item functions in the instrument. Now, I hope you learned from that discussion. So I have prepared a data sets. I hope you can access the data sets, and I also hope that you're able to install in your gadgets or in your laptop a free trial version of the software. Now, I think if they are ready to do the analysis, sir, I think we can group them. Your task is to conduct an exploratory factor analysis of the prepared data sets, and then you're trying. You will be answering this question: is the matrix is factorable, and if so, what would be the number of factors or factor solution to be retained, and then name the factors, and then if possible support theories why you name or you give labels to the retained factors. Again, using the data sets, you're going to determine whether the correlation matrix is factorable. And if so, how many factor solutions do you need to retain? The factors that are reasonable. And then name the factors. So in the data sets, there are questions there. There are the label. There are questions, and then after the extraction of the retained number of factors, name that one, and again, it's much better you can support the theory, because in instrument development, most especially in the social sciences and in psychology, we base the labeling of the factors based on theories. Okay, so that is our uh, that is the thing that we can do in labeling our factor solution.
Sir,
Sir?
there are some posted questions and some concerns here. One of our participants asked if are there any instructional manuals for these procedures that you have presented so they may be able to follow it, as well as siguro po they will have future references if they would be able to use factor analysis in their future endeavors as researchers.
Okay, thank you for that question. You can, I think you can secure an online or a digital version of the book of Andy Field. You can use the book of Andy Field. It's focused on how you can use SPSS. And there also, I suggest that you also read research articles and how they utilize exploratory factor analysis. Again, as I have said, the way we develop our instrument is guided by theories, and so it's more onto art rather than a science. We use the concept of correlations. We use the concept of matrix and linear algebra to extract factors, but our judgment in naming or in writing our indicators that can measure a latent trait. When you say a latent trait, these are construct that cannot be measured directly. So it means we cannot use, let's say, for example, if you put it this way, we can directly measure distances or the distance between 2 points through a measuring instrument, but we cannot measure a trait or a latent trait. Let's say, for example, we cannot measure directly a latent trait. Let's say our emotional quotient, our intelligence. And so it is really hard to label factors and to select items or to graph items to represent the latent trait if we don't have theory. So similarly, when we try to refine the instrument, it's more into art, meaning we still adopt theories, and so the use of the statistical software should be guided by your knowledge about the trait that you are investigating or you are trying to measure. Okay, so but again, you can use the book of Andy Field. I think you can search that one, and I suggest also to read research articles that employs a factor analysis. I hope I have given you some tips and insights. But again,
Thank you very much, sir.
there are many books and manuals, most especially in IBM. I think IBM provided with user manuals on every version, but I haven't downloaded because in our university we have books we have books about how to conduct exploratory and let's say confirmatory factor analysis. So we don't refer to one books, but we have a lot of books in our library. But again, I think IBM has provided with a user manual in every version of SPSS, and maybe you can search that in the website, in their website. Hello, sir.
Yes, sir. Thank you po for answering the question and concern of our participants. Again, to our participants, here are some instructions before we proceed with our workshop. First, you need to conduct an EFA. Yun po yung first instruction from Sir Gagani. Next is how many factor solutions are reasonable. You have to answer that question, and then you have to explain why. Then after that, you name the factor solutions. Sir, somebody asked if is it going to be just like what you have demonstrated us earlier, yung gagawin naming workshop? Sorry. Okay, before we proceed with that concern po, if you are asking for the attendance sheet, ang link po is bit.ly, hindi po bit/. Okay, para po ano tayo, clear tayo, bit.ly/FA day 2. It's working po. You may copy the chat that I have sent right now and then paste it in your Chrome so you can access our attendance. Okay. Again po, sorry. Somebody asked if yung gagawin daw po ba namin sa workshop would be just like what you have demonstrated to us, so that we would come up with the answers for the questions you have provided. Sir, I think your microphone is not working po. While we're waiting po, to our participants, if you have some concerns or there are some questions that you need to raise right now, then you may do so. Please chat it using direct message or the send to everyone message so we can see your questions.
Hello, sir. Good. I was
Yes, sir.
disconnected. What was that again, sir? I was disconnected.
Okay po. Sir, meron pong nagtanong dito that yung gagawin daw po ba ng mga participants in the workshop right now would be just like what you have showed us earlier? Yung entire procedure po na ginawa ninyo.
In my example is, can I be heard? In my example, I use orthogonal rotation, but again, you can further explore. You can use Promax for oblique rotations. Try to see the questions there now in the data sets. That's why you need to provide your reason. If you think those indicators or the factors can be correlated, or if the factors are correlated, or if you assume that it is correlated, then you can do oblique rotation. So one of the oblique rotations is the Promax. And then try to compare the result when you specify the numbers of factors to retain. Hello, sir?
Yes, sir. So basically, sir, our participants can have the luxury of exploring alternatives in using the SPSS.
Two possible, yes. They can do the orthogonal rotations, then they can also have the oblique rotations, because again, our judgment should be backed up with our theoretical knowledge about each of the indicators and the factors. So, but in social sciences, it is really assumed that the factors are really correlated, because it is in social science, it is very hard to establish a causal relationship. But we know that some of the, or most often, the factors are correlated. But again, we need to back it up. Why do you think so? That the factors are considered correlated factors. So you can explore. So it's in this idea that we refer our judgment to our working knowledge about the factors and the relationship among the indicators, because there are already previous studies investigating some factors. Let's say, for example, about or lack in trait, for example, about intelligence. And so there are many other researchers examining how the working knowledge about how people utilize intelligence in, let's say, for example, in answering a test item, and what are other factors that might affect their performance. And so there are existing literatures to support that. And so there are literatures stating that two or more factors are correlated. Let's say intelligence and our comprehension level might be correlated. And so if you think that there are items talking about comprehension, and there are items talking about fluid intelligence, so you might say that, okay, these two are correlated. And so if these two items are distributed to one of the retained factors, so it is assumed that there are also the existence of this correlation. So that's why we also use these oblique rotations in most social scientists. I mean, most studies in the social sciences utilizes oblique rotations. Okay, and then try to compare if you use orthogonal, then the oblique rotation, and what happens to the distribution of these items to the retained number of factors. Again, your judgment and your decision whether the factors are correlated or uncorrelated depends upon your knowledge about the latent trait that you are trying to measure. So it entails a lot of readings.
All right, sir. I think this one is for the breakout session. Thank you very much for answering. Since we have some disconnected participants right now in the Zoom, we are currently 33. And may we ask permission that we will only have two groups, considering that some of our participants have not installed the SPSS trial version. But then for our participants, if you wanted to try and install the SPSS trial version, I have sent the Google Drive link in the chat box, so that you may be able to access the data presented, the data that is going to be used for our workshop, plus the application. So let me just share my screen for you to be able to see what the drive looks like, and I might as well guide you as to how you are going to install it later on. For now, for the workshop, we will have facilitators. This is according to bmts. So the two facilitators, or our facilitators for the two rooms that we will be having, for room number 1 would be Ma'am Vanji Pailmao and Sir Ray Gagani. And then for group number 2, Miss Chona Futalan and yours truly. So we will be having different rooms, and I have already installed SPSS in my laptop. So you could just rest assured that for group 2, we would be able to use and view the data using the SPSS trial version. And sir, may we request that for group 1, if ever there are no participants who have not installed the SPSS yet, then okay lang po ba sir na kayo na lang po yung mag-share ng screen later on? or si Miss Vanji po. Okay, while we are waiting po, I'll just share the screen, for which if you have clicked the link that I have sent, ito po, isi-send ko po ulit right now in the chat box. Yan lang po muna ang i-click natin if you are interested. Might as well, sayang naman po, we have the free trial version of the SPSS. This works on laptops that are 64-bit. No, so yung mga 32-bit po, may version po doon sa link na sinend ko earlier. And may also request everyone to mute themselves muna. Ito po yung link. If you are going to click the link that I have sent, ayan po, dalawa yung inyong makikitang files. So yung first file po dyan, yung may extension na .sav, that is the working data that we will be using for our workshop. Now, the second one, yung .exe, yan po yung installer ng ating SPSS trial version. So all you have to do is to download these two, install it, and in my experience, matagal-tagal po yung yung pag-i-install, and it requires rebooting. So if you have an extra gadget with you right now, then you may use that one for installation, because you might be interrupted in joining this Zoom meeting if you are going to reboot your computer or laptop. So again, yun lang po. So some more questions or concerns po before we proceed? Okay. So si Ma'am Vanji Pailmao has not downloaded the app yet. Everyone, I think this is a lot easier. So please try downloading the app that is on the drive. I think mas maliit na siya as compared to when you directly download it in the website. Okay? Ayun lang po. So I'll now assign you to breakout rooms. And sir, how many minutes po ang ating ilalaan for this workshop? Sir Ray? Or would it be for 1 hour, sir?
I think maybe
It seems our speaker is disconnected. So may I ask some of our committee in charge as well, what do they think about our time restriction for our workshop?
Hello, Suri. We can actually have 5 minutes for that, since some of the participants will be still installing the app and download the data set. Then with that, they can work out with the data set. So we can have a maximum of 45 minutes. And then we can ask a volunteer in each group to screen share their output or the steps on how to perform the factor analysis.
All right, sir. So again po, for our participants, we will be having 45 minutes for the breakout sessions. Now for our live viewers, please, you can try installing the SPSS as well. You may see the comment for about siguro mga 5 minutes po after I have set the breakout rooms. For now, just sit back there and try to explore on SPSS using the IBM website that I'll be sending later on. And then, please be back after 45 minutes. All right. Thank you po, Dr. Awunzo. So I'll now assign you to two different rooms. The attendance link, by the way, is going to be sent in the chat box right now. Okay, so ang attendance link po natin ay bit.ly/FA-Day2. F and A are capital letters. Alright? So, I think okay na po tayo. Shall we have our breakout session? So, I'll open the breakout sessions, and for our participants, you may start joining. Again, for our Zoom participants, you may start joining our breakout rooms. And for our YouTube participants, please wait for the link of the drive that I'll be sending siguro mga 2 minutes or 3 minutes po after all the participants have joined the Zoom breakout sessions.
completely descriptive.
we will change if there is significant relationship between the profile of parents, profile of parents who with the knowledge on OSD and the challenges. That's all. And then
Again, sir, please.
is
Is
there
there
is there a significant relationship between the profile of parents and their knowledge to their knowledge
Still a blessed morning to everyone. We are now able to finish the breakout sessions, and I hope the two rooms and two breakout rooms have been able to accomplish the task assigned to us. Now, maybe we could ask the group one if they are ready. Room one or Sir
Yes, sir.
Alonso? Yes, Sir Ananias.
Okay, so a pleasant morning to everyone. By the way, I am tasked to present the output of. Mo present ako, sir? Should I be present? Should I present, sir?
Yes po, you may now present, sir.
Okay. So again, good morning, everyone. So I am tasked to present the collaborative effort of Group One on on doing factor analysis of the given data set. No? Okay, so the first thing that we did in the in doing the activity, of course, we tried to analyze the data sample or data set if it will qualify to the, how do you call this one, the guidelines, or not the guidelines, but the conditions as to whether it will satisfy the conditions to do such factor analysis. Kasi there are data set that if you're going to test this one, it is a must to test kasi the data set if it will qualify to what we call as to the factor analysis or not. And one of the measures given or provided to whether the data set will be good in subjecting doing factor analysis no is Tong Kaiser Mayer Olkins measure. And if you're going to look at the data here or the results, so it is 0.9, it is, of course, it is good. And of course, another area is, or dimension is what we call as a Bartlett's test for sphericity. And if you're going to look at the value, so you have here a significant value, of course, which is, actually this is not necessarily to be 0, 0, it is a quite small number. Okay, so next slides, please. And if you're going to, after doing the analysis, kasi we've done an analysis. So in the analysis kasi, prior analysis, we found out that there were two dominant factors. So out from the given data set, we can really see, based on the square plot here, that there were two dominant factors. Okay, so you have here, so, and the rest, of course, they are just but of the same. Okay, so we have here two factors. And of course, we do further analysis. First, we did orthogonal analysis, but we cannot see the beauty of the data set using the orthogonal analysis. So orthogonal analysis is actually basically tells us the uncorrelated factors. That is why, since we cannot see the beauty in it, that is why we proceed to the oblique rotation. Okay, so trying to see the patterns of correlated items. Next slide, sir. Okay, so given with that, there were two factors, as what I have said a while ago. So there were two factors. So what are these two factors? Okay, based on the data set, we have here the first factor, wherein we baptize this one as content, knowledge, competence. Okay, so if you're going to look at the factor loadings for this one, for this factor, so I mean, in looking into the group and the grouping or the factors, you have to look into the factor loadings. In this case, we set factor loadings which are greater than 4. It will be grouped. Okay, so those factors which are less than 4, of course, it will be excluded. That is why in our result, in our items, I mean, in our analysis, there were items that were excluded kasi it doesn't qualify to the minimum factor loading that we set. Okay, so we have here this 12 questions. We categorize this one as content knowledge competence because if you're going to look into the data set or the given questions, it pertains to the competence of the teachers on a particular subject matter. Okay, so next slide, please. And we have here the factor 2, and we baptize this factor 2 as pedagogical knowledge competence, or the PKC. So if you're going to look at the set here, again, you must pertain to the factor loading. Anyways, in the analysis kasi, we just all the items were in the factor loading is less than 4, na tanggal na agad yun. Okay, so this is the result for factor 2. Okay, so if you're going to look into the items, we can correlate this one or associate this one, I mean, to the pedagogical manifestations of the teacher. And for the last items, or those items that were excluded, so we have here for the next slide, these were the items that were excluded kasi the factor loading doesn't satisfy the minimum requirement. Okay, so meaning to say that these items, if you're going to look into the final, if you're going to look into the final test, or I mean instrument, this one will have to be excluded. Okay, so that's it for the collaborative effort of Group 1 in doing factor analysis.
Congratulations, Sir Ananias and Group 1.
Thank you, sir.
Thank you so much, Sir Ananias and room number 1 or breakout session number 1 for giving us a comprehensive discussion about what you did for our workshop. And I'm glad to see that most of us here have been able to understand the process as well as the interpretation. Now, in case for the group number 2, I am included there, and let me just present our work. Now, our work here is somewhat still in the process, as you can see, because we have had a tough time remembering all the processes on how we are able to do the factor analysis. But perhaps this is what we have accomplished so far. So considering the discussions that the previous group had, for our case, we have found 6 components and disregarded the factors having lesser than 0.1, just like mentioned in the discussion. But then later on, we have decided that we will instead use 0.3 kasi nga po, there are some components that are overlapping at the same, let's say for the first situation there, answer students questions with confidence. Some of the components appear to have values for several components, which is why we have transformed and changed the value into omitting the values lesser than 0.3. Now, the challenge in our group is that we have no participant who is not able to have at least a little knowledge, or basically basic knowledge on how we are going to have the next steps as well as the analysis for this table. And so we have stopped here, and siguro po that is also the concern that we are going to bring up to this discussion for our session for today. So that is the group 2 work. So thank you po, and let's go back to our speaker. Sir Gagani, any comments po or suggestions?
Hello, sir. Okay, thank you for sharing this output, sir. So in the first group, they explore the possible number of factors to be retained. Then we examine there the script plot, and it suggests the script plot suggests that there should be two factor solution to be retained. So can you present your output, sir?
Yung
Now,
sa group to, sir?
now this is now our working knowledge about the factors comes in. If you notice, there is this initial factor loadings. You use 6 factors, right? Or 5 factors, I think 5
Yes,
or
sir.
6.
6 factors.
Can you present, sir, your output?
Okay, for a while po.
Hello, sir.
Yes, sir, for a while po.
Can you present the variance table, sir? The variance there, this one. So these are first 4 columns here. We have the initial eigenvalue. Actually, this is the result when the software perform principal component analysis. So that's why we have initial eigenvalue. So others author decide which to use. Either they will use after they explore on the factorability of the matrix. Authors decide to use decide whether they use the principal component analysis or the factor analysis. Okay, so it's a matter of decision making here. Now, if you think that these 5 factors here or 6 factors are reasonable enough to be retained and it is backed up with theories, then you can have the principal component analysis. Okay, so you can go to analyze and then conduct a principal component analysis as the method. Okay, here we use the principal axis factoring, and that is your method, and it considers the possible sources of variance that explains that contributes to the variance of the observed indicator. But in the principal component is it just only consider the weight of each factor to make a single index score. So again, if you think that five factors or 6 factors are reasonable, then you may use principal component analysis, not the factor analysis. In the second group, we use the factor analysis, and then we retain 2 factor solution as presented, and then we label that one according to our preconceived ideas about teacher competence and then pedagogical skill. But again, this initial eigenvalues can be used in the principal component analysis here. So retaining either 5 or 6 possible factors. But there is this what we call the parallel analysis that really helps us how many possible factor solution to be retained. And it supports our script plot. Can you go back to the script plot, sir? Do you have the script plot? Here. As you can see, there are about 2 dominant factor solutions here. Now, let's try conduct principal component analysis. Can you present to us the data set, sir? Data sets. Let's try to analyze that one using principal component. The
Which
data
data,
sets.
sir? The original data,
The
sir?
raw data, yeah, the raw data. So let's go to analyze. And then we conduct a principal component analysis. So we have dimension reduction and then factor. Okay, so kindly reset, sir, reset all the variables here. Okay, and then select all the variables. You can highlight all and then transfer it to the this window. Then you can have descriptives. Then we have univariate statistics. And then you can check coefficient, the KMO, and the determinant. And then continue. And then our extraction method is here. We'll use the principal component analysis. Okay, and then we have click script plot. This one, just script plot, and then continue. We will not rotate it yet, sir. Just leave it. Just cancel this one. And then click OK here. Click OK. We run the principal component analysis. Can you show the output window, sir? Kindly locate the principal component output. Kindly check the script plot, sir. That's the script plot and the variance table. The variance table and the script plot. Okay, here. Try to observe the. Let's have this first. As you can see, it suggests that there are the total variance explained. There are 6 possible factor solution in this principal component methods of extraction the possible factors. Then let's proceed to the script plot. So as you can see here, the script plot seems to suggest two dominant factors here. We have the factor 1 and then we have factor 2, but as you can see, there is this irregular portion here of the script plot. No? It seems to level off here, and then again we have another the dimension here of the tool, and before we have this sort of the oval which started to level off. Okay, so as you can see, we need to really examine this further. How many possible factors we need to retain? So in this case, I suggest we will have these two factors. Okay, so we have factor 1 and factor 2. So in this data sets or in this example. Okay, so can you see the difference between the script plot of the method of when we use the principal axis factoring as the method of extraction, because principal component or principal axis factoring is the real factor analysis in the Spss software, but here this is the principal component analysis. But this principal component analysis suggests two possible factor solution. So can we go back to the variance table, sir? Okay. So we have, okay. So this principal component really suggested six possible factors. But we can have, again, we can have parallel analysis to really check how many factor solutions we need to retain. So may I share, sir, my screen?
Yes, sir. Go ahead po.
So I will go to this website. So there is this engine in which we can conduct parallel analysis. Okay, so I will perform first the principal axis factoring. Where's the share screen button? Here. Can you now see my screen, sir? Participants?
Yes, sir.
Okay, so here I will analyze this one using principal axis factoring. Suppose I will be having this, we'll use extraction method, which is the principal axis factoring. Let's take the script plot, and then I will choose, let's say, oh, let's have this one, the eigenvalue, which is above 1. Then I will not rotate it first because I want to check how many factor solutions I need to retain. Then click OK. Be having this, we'll use. Now this principal axis factoring gives more interpretable script plot compared to the principal component analysis. So here, I will try to identify how many factor solutions that are reasonable to be retained. So here, as you can see, extraction sum of squared loadings, it tells me in this portion here that I should retain two possible factor solution. Because as you can see, when we have this one in the third factor, it is less than an eigenvalue of 1. Okay. However, the two factor solutions contributes only about 30% of the total variance. And remember that the literature suggests above 50. But again, in social sciences, we have so many considerations because there are many sources of, or there are many factors that might also contribute to that variance. Okay, so we need to consider the theoretical underpinnings of the situations we have. So here I will compare, I will conduct parallel analysis. So there is actually an engine that we can use here. So can we go to this page, analytics.gonzaga.edu / parallel engine slash. So here I will just input how many factors I have. So in that case, we have 30. And then the sample size, let's check the sample size. Can you see the web page, sir? Dear
Yes, sir.
participants, okay. So there are how many cases here? You have 265. So I have 265. And this engine generates a random eigenvalues. So I will have 95 percentile. I will have this one. You can also have set this 99, but I will stick to 95 percentile. And then let's try to compare the randomized eigenvalue to our computed or observed eigenvalue. So where's the variance table here? Okay, so let's compare our initial factor loading or initial eigenvalue. Let's minimize this one. Oops. It's me for a while. Okay, so we have this initial eigenvalue. Again, this is actually computed through principal component analysis, that initial eigenvalue. And so we try to compare it here with our randomized eigenvalue. So in the first factor, as you can see, our value here, our observed eigenvalue, is larger than the randomized eigenvalue. So in the second one also, we have a higher observed eigenvalue than this randomized eigenvalue. But notice in the third, here in the third factor here, the observed eigenvalue is less than the randomized eigenvalue. This one is 1.5 and this is 1.4. So that tells me that it is reasonable enough to retain these two factors here. This one. Okay, so as you can see, this table suggests that we should retain two factor solution. And so by this, we proceed conducting the factor analysis now. And then we rotate. Now let's say I will use a Promax since I believe that the factors are correlated. Then click continue. And so I will sort according to the size. And then I will adjust. Let's say I will use a threshold of 0.4 instead of 0.3. And click continue and then click OK. So I was not able to set, let's go back again. I was not able to set the number of factors to be retained. So we have the number of factors, we have 2. Then continue and then okay. So here we have this interpretable pattern matrix. Now notice that when you use oblique rotation, what we are interested examining is the pattern matrix. Okay, but when we use the orthogonal, we have the factor matrix when we have the Varimax rotation. So this matrix suggests that there should be these items loading on this factor 1 and these items loading in factor 2, and the rest of the items which has less correlation value, which is 0.4 or less than 0.4, is not reflected in this table. But it was included in the analysis, but it is not reflected because the value is less than 0.4. Okay, so again, we can conduct parallel analysis to double check how many factors we would like to retain. If our analysis, we are sure that we need to conduct a factor analysis. But again, other authors, they tend to compare the result of the principal component analysis and the result coming from the factor analysis and decide which result should be reported. Again, it's a matter of decision making and supporting our ideas with theories and previously published or the currently accepted standard about a certain latent trait that we are trying to measure. So it means that we need to use those published research. Okay, so again, let me repeat. It's a matter of choosing now which of the extraction method will you use. Either you will use the principal component or you will use the factor analysis, the principal axis factoring. Again, in Spss, principal axis factoring is the factor analysis. In my presentation this morning, I differentiated the difference between the principal component and the factor analysis. So here, we can really see the difference of the two extraction method. Now, the script plot, as presented by Sir Rinaldo, the script plot, when we use the principal component analysis, is not so much interpretable compared to this. But that is not the usual case. It's just in this case that script plot seems not to be more interpretable, or it doesn't give us a more clear information than this script plot coming from our factor analysis. And then, so we name this one according to our knowledge about these indicators and what these indicators tries to represent. Okay, question, clarification? Sir, go back to you, Sir Rinaldo.
Thank you so much, sir, for the very comprehensive explanation. I believe that the participants of group number 2 has been able to absorb as to how we are going to pursue after we have administered the principal analysis. Now, if for the rest of us here, if you have some questions po, you may use the chat box. I think wala naman po, sir. So, sir, any final words po for our live viewers as well?
So thank you for today's participants who have tried their best to really go into understanding what is factor analysis. So I guess I have to call Dr. Onzo if there is any word from him. Once again, thank you for listening. If you have some questions, you can reach me through my email.
Dr. Alonzo, any words po?
Yeah. Thank you everyone for joining. Ano na lang, parang For those who will be asking questions or for those who wish, kasi may narinig ko kanina about path analysis na meron din sanang seminar workshop, just message us through our email that's na binigay namin sa mga flyers namin para we can find out kung ano yung mga needs ng iba pong participants para mapaghandaan namin for our next webinar series po. Yun lang po. Back to you, Sir Ray, Naldo.
Thank you so much, Dr. Alonzo and Professor Gagani, for all your suggestions and for the discussion for this day. Indeed, this is a very productive day for all of us, and we have learned a lot through this webinar. Now, this will not be ending without the closing remarks. So let me call on the person in charge for the closing remarks. So let us hear a message from the Vice President for International Linkages of BEMTS, as well as the instructor of Trinidad High School from Colorado, USA. Let us welcome Miss Queenie Ipanto.
My name is Queenie Ipanto, and I'm the BMTS Vice President for International Affairs. I'm glad to do this part of the program, but sad at the same time because that means that this session has come to end. Since this is inevitable, let me start my concluding remarks by expressing my appreciation to our very own Ray Gagani for his beneficial contribution to our 3-day seminar workshop on conducting and interpreting factor analysis as we celebrate the National Teachers Month. I am convinced that the most valuable outcome of this event is empowering all educators to perform data visualization and data reduction to inform, engage, and create opportunities for our students. The BMTS, or the Basic Education Mathematics Teachers Society Incorporated, is committed to promote research and education data to make sense in our basic education system. As for the outcome of this workshop, is aimed to a more effective evaluation of programs and to a better assessment of our students' performances. Whatever role you're holding in our education system, on behalf of the BMTS officers, I thank you for sharing your whole weekend morning with us on top of your other chores. And my deepest thanks are of course reserved for the City of Mandaluyong Division for their priceless contribution and for running a smooth event. I, and among others, believe that events like these are useful and should be continued as there are a number of areas where the combination of data and education is practically promising. Thus, let me end by saying, hoping to see you in another seminar workshops and continue to collaborating with our partner in this endeavor, the Department of Education. Thank you for your undying support. See you on the 30th, the last day of our 3-day seminar. Again, thank you. Have a good day.
Thank you so much, Miss Queenie, for that warm and wonderful closing remarks. So again, let me invite and remind everyone of the last session that we will be having. That is for next Saturday, 30th of October. And that would be the day 3 and final session. Also, I would like to give my thanks to the SDO Mandaluyong City, SDO Marikina City, and SDO Parañaque City for also helping us in doing this event. Special thanks also to our BEMTS family and officers. Again, this is your host for today, Sir Ray Collado, saying stay safe and God bless us all.
Thank you, Sir Ray. Goodbye, everyone.
Thank you, everyone. Bye.